Hey everybody, this is Mr. Munson, and we're in Unit 8, Quadrilaterals. And of course, we're on concept number 4. So this video is called 8.4, Trapazoids and Kites. So if you look at your student learning map, concept number 4, there's a list of I can statements there. And so by the end of this video, you should be able to identify those I can statements as being able to do it or not. To what degree, that will depend on your practice in class next time. Let's get started. Okay, let's get some vocabulary word back in the way there. Get it out of the way here. First of all, in a trapezoid, we have two sides that are parallel, the other sides are not. So we only have one pair of parallel sides. That's what makes it a trapezoid. By definition, the very first one pair of parallel sides. If it had two pairs, then of course it would be a parallelogram. Hey, listen, in a trapezoid, the two sides that are called, that are parallel are called bases. Okay, so we can call this one base 1 and base 2. The sides that are not parallel are called legs. All right, very good. Now, in addition, we have diagonals in these shapes. And then we also have interior angles. Okay, so if you take a look at this next attribute of a trapezoid, we see that two pairs of consecutive angles are supplementary. What that means is, let's go ahead and put in some lower letters here to represent the numeric numbers of these angles. Okay, so it says two pairs of consecutive angles that are supplementary. These two angles, that angle A and angle B, are consecutive. They're right after each other. But these are not the pair that are supplementary that add up to 180. It's actually, this is one pair, right? A and D. The reason is because they are the two interior angles that go along with the parallel lines. The other set are these two over here. Okay, so those two sets are supplementary. A mid-segment is basically a segment that connects a midpoint from one side to another. Okay, so in this drawing for this trapezoid, we have a mid-segment there, and what we find is that that mid-segment is parallel to the other sides. Another attribute is that the mid-segment has a relationship to the bases. So if you take a look at the equation I'm writing, the mid-segment, B1 plus B2, when you add those together and divide by 2, they equal the mid-segment, okay? So put that on your formula sheet if you don't have it there already. And then let's see, I think that's pretty much it. All right, let's go ahead and look at some problems here. So I want you to go ahead and take the information here, put it into the drawing, put me on pause, and then use these attributes over here to either come to some conclusion that they're looking for, write an equation, whatever you need to do to find the missing information. Okay? Go ahead and put me on pause and see if you can do it on your own. Okay, welcome back. If you're here to check your answers, we're almost there. If you need some help, once I kind of get you started, you might put me on pause and see if you can think the rest of the way if you got stuck, okay? So one of the things that I know is that that angle and that angle are supplementary. They add together to equal 180. Now you might have already figured out what the actual measurement is, but let's just call it x. So I know that one of them is x, the other one has to be an x, and when I add them together, they should equal 180. So that leaves us x to be 90 degrees. Okay, so I'm hoping most of you were able to figure that out on your own. So we know that these are 90s. Cool. Now the other missing angle is this one here. So to do that one, we could call it y. So I know that the 90 plus the 90 plus the y plus the 48 should equal the sum of all the interior angles of a four-sided figure. Now we learned that in section 8.1 to be equal to 360. So now it's just a matter of us solving for that y. All right. And if I did my math right, you should have gotten y equals 132. Now you might have chose a different letter than y, but that's okay. Let's move on. All right. In the world of trapezoids, we have a special trapezoid. It's basically a trapezoid where the legs are congruent to each other. Okay. So when that happens, we get a thing called an isosceles trapezoid. And by definition, the legs are congruent. That's what makes it an isosceles trapezoid. But once that happens, then some special traits come about. that are different than just everyday trapezoids. First of all, the base angles, and we'll talk about what those are, they're congruent to each other, okay? And the diagonals become congruent, just like a rectangle does, okay? So let's take a look at base angles are congruent. What that means is that this angle here and this angle here are going to be congruent to each other. But since AB is also a base, we'll call it base 1, we know that these two angles are also base angles, and so they're congruent to each other, okay? Pretty easy stuff. So again, all these attributes allow us to think about what kind of equations we might write to find x or y or something where we see a relationship between two things like this, right? Now, keep in mind that in this trapezoid, these two sets of angles are still supplementary because they're trapezoids and they're between two parallel lines. That's old news for us from chapter 3. All right, let's look at some problems and see if you can take these newfound concepts and apply them to writing equations. Take a look at example number 2. See if you can do this one on your own. Put me on pause, then come back and check your work. Okay, first I found that angle D was equal to 65, and that's because base angles in an isosceles triangle are congruent. That's not in every, isosceles trapezoid are congruent. Okay, that's not true in every isosceles, but in these, not in every trapezoid, but in isosceles trapezoids. Now, angle B is equal to 115 because of consecutive interior angles are congruent in a trapezoid. That's true in every trapezoid. Now, I need to find x. I'll put my information in as I just found. And so what I find is that either I can write the equation x plus 12 equals 115 degrees because base angles are congruent, or I could write the equation x plus 12, plus 65 equals 180 because in a trapezoid, the interior angles are the pair of angles between the bases are supplementary. Okay, either way I can solve for the x. It'll be the same one. I find the x plus 12 the simpler of the two. So we find x is equal to 103. Next one. Go ahead and put me on pause so you can do example 3. All right, I found x to be equal to 3. Now the equation I wrote was based on the fact that in an isosceles trapezoid, just like in a rectangle, the diagonals are congruent to each other. Pretty easy stuff. All right, go ahead and see if you can do this problem. We recognize that, I'm sorry, let me put some letters here that are missing. This should be E, and this is F. And so segment EF is a mid-segment because I can tell that one point that the segment is based on, the one point here is a midpoint. This is congruent to that, to this other piece. That tells me it's a midpoint. This other one's a midpoint because, well, it's between two segments that are congruent to each other as well. Okay, so we know that this is a mid-segment in a trapezoid. Any trapezoid, doesn't have to be an isosceles trapezoid, and so there's a relationship between that mid-segment and each one of the bases. Okay, so go ahead and put the information into the drawing. Put me on pause. Refer back to the equation I gave you earlier about the mid-segment. See if you can do this on your own. Okay, so I did this problem wrong. Let me pause for a second. I'm so sorry. All right, and there we have it. X equals 3. Okay. Of course, when I plug it back in, I might get numbers that are not, they don't fit in the drawing really all that well. The thing's not necessarily drawn to scale. But I could kind of take a look at what's going on. So if I plug that 3 back in, I get 2 for the top one. I get 5 for the middle one, and then 8 for the last one. And what I'd be looking to see is just this 5. Do I get this 5 when I add these two together and divide by 2? And I do. So that means I did my math right. Okay, so when you look at the mid-segment formula, you'll see there's an unknown here. So if I have the mid-segment, like this one, I can stick it right there in that spot, the x plus 2. But there's also a B1 and B2. So I can use, if I have any two of these unknowns, if I have these two right here, these numbers in a drawing, then I can use those to find the mid segment. If I have the top or the B1, the base 1, and the mid segment length, or some whatever, then I can use that to find B2, okay, and so on. All right, let's move on. All right, let's talk about kites. Some of the things that we find out about kites is that the diagonals are perpendicular and so on, okay? But by definition, what makes it a kite is, first of all, there's no parallel sides on the kite, okay? But what makes it a kite is that you find that two pair of consecutive segments are congruent, okay? What that means is this segment and this segment, which live right next door to each other, are congruent. And then this segment and this segment, which live next door to each other, are congruent. Notice that the opposite sides are not congruent, right? That would be a parallelogram. You know, that if the opposite sides would be congruent. Okay, so by definition, two pair of consecutive sides are congruent. Then once that happens, when you take a quadrilateral and you make that happen, you also end up with a pair of opposite angles that are congruent. Okay, so let's look and see where those are going to. Now, if you take a look at these diagonals, one's obviously longer than another, okay? That will give you an idea where these congruent angles are. The congruent angles are not on the long side angles. They don't point back and forth to the congruent angles. Matter of fact, if you look at this one over here, it's definitely larger than the one at the bottom part of the kite, okay? So it's the short diagonal that tells you where the congruent angles are. So we know that this angle and this angle are congruent to each other. That's that trait. Also, another one is the diagonals are perpendicular. So once that happens, I can put right angles in there. And then finally, only one diagonal is an angle bisector. Okay? This diagonal, the one that touches the congruent angles, is never the angle bisector. Okay? It'll always be the longer one that is the angle bisector. So it cuts the angles over here into half. So each piece is the same. And I'm going to go ahead, let's go ahead and use this kind of notation for these angles so I don't get them confused. And then down on this side, on the right-hand side, you have this angle. Let's get rid of that. I have this, and we'll use two strikes for this set of angles that are congruent. Okay, so there's the traits of a kite that you'll need to memorize, and then use those as you're writing equations. So a pair of angles that are congruent, you can set them equal to each other. Diagonals are perpendicular, that brings in a 90-degree angle. Slopes are opposite reciprocal, those kind of things, right? And only one diagonal is an angle bisector. Well, when we find out where that's at, we can take the whole angle and cut it in half to get an angle. Okay? All right, let's take a look at this problem. Go ahead and put me on pause. Put the information into the drawing. Put me on pause and then come back and see if you figured it out correctly. Okay, so I went ahead and marked the drawing. Now there's certain things I can assume now, but since it's a kite, that 110 is also on this side, so we'll go ahead and put it over there. Okay, now since it's a quadrilateral, I know that all four of those angles have to add up to 360 degrees. And therefore, I conclude that it's 75 degrees. All right, that's not really necessarily a kite thing, you know, they add up to 360. That's a quadrilateral thing. But to get to that, you had to know that this angle over here was congruent to that one. That's a kite thing. All right, go ahead and do the one on the left-hand side. Come back and check your work, see if you got it right. All right, there we have it. Opposite reciprocal, right? As soon as they start talking about slope and we know that these things are perpendicular, we're going to use these two words to help us formulate what that is, okay? Opposite reciprocal. Let's move over to the one on the right-hand side and see if you can do that one, okay? Put me on pause, come back and check your work. Okay, so here we have it. The first question, the measure of DAB, this whole angle is 70 degrees, and since the red one is an angle bisector as a characteristic of a kite, that the long one is the angle bisector, I just simply cut it in half. That's easy enough. Okay, so if the whole angle was 3x plus 2, and there was some more information, we might be able to write that the large angle is equal to half of the smaller angle, right? Okay, then we have AED, and I apologize, you might not have known where point E was, but E is where the intersection is. Now it's asking you, what is AED? So we have AED That's 90 degrees because the diagonals are perpendicular. Okay, so here's your do it problems. Let's go ahead and get a little bit closer to them so you can see. Looks like the first one there is a mid-segment problem. It's going to be a trapezoid. What's the characteristics of the angles? Isosceles trapezoid. What's the characteristic of the angles? What happens there? It's going back and looking at the diagonals. We did a problem like that. And here's your kite problem. Get all your information visible there. Okay? All right, fantastic. Good luck with that. Stop by and see me if you have any trouble. It's pretty straightforward. See you next class.